Hey guys, welcome back to my channel where we explore interesting math problems. Today, we'll be looking at an algebra problem from the 2022 Canadian Math Contest format, which is for 11th graders. The contest has 25 questions, with the questions ordered from least to most difficult. The question that we'll be looking at today is question 24, making it one of the hardest questions on the contest. So the question reads, there are functions f of x with the following properties. F of x equals ax squared plus bx plus c for some integers a, b, and c with a greater than 0. And f of p equals f of q equals 17. And f of p plus q equals 47 for some prime numbers p and q with p less than q. For each such function, the value of f of pq is calculated. The sum of all possible values of f of pq is s. What are the rightmost two digits of s? So let's first look at this given function and these equalities. There's not much we can do with it at the moment, and if we want to find f of pq, we will likely have to find what these constants a, b, and c equals to. So let's first plug in p and q into the equation to see where it will take us. Plugging in for f of p, which equals 17, then for f of q, which is also 17. Now looking at these two equations, you can see that the structure is very similar. We have the constant a here, b here, and c here by itself. So maybe we can do some equation manipulation to get rid of c to decrease the number of variables we have to work with. Let's first try with subtraction, which will get us this. And since p squared minus q squared can be expanded into this form, we can take advantage of the fact that p minus q appears both here and there to divide the entire equation by p minus q. So we're just left with this much cleaner looking equation. Now let's bring in the other piece of information we were given. F of p plus q is 47. Plugging it into the given function, we get this. Then we can factor out p plus q because both of these contain it once. And here's where the magic happens. Do you notice something familiar? This factoring of p plus q is deliberate, and if you were watching carefully, you might have noticed that this is exactly equal to the expression we have here. And since we know that this is equal to 0, we can go ahead and plug that in here, which makes this entire part 0. So we're just left with c equal to 47. Now we need to go find a and b. One way to do that is by using the equation that we've previously established. And plugging in c, which is 47, subtracting it from both sides, we get this. For the left equation, we can factor out p, and for the right, it's q. And since the question told us that p and q are prime numbers, which means that they must be integers, and that a and b are also integers, this means that p and q must be an integer factor of 30. So we factor 30. And since we're also given that p is less than q, this gives us three possible scenarios. First, p is 2 and q is 3. Second, p is 2 and q is 5. And lastly, p is 3 and q is 5. Now let's work through each case using these two equations to find out what a and b is in each respective case. For the first one, plugging into the two equations and simplifying, we get this. To solve for a and b, we do some quick equation manipulation. Take this one and subtract it from the other. This cancels out the b and leaves us with a equals 5. Now we plug back a to find b, which is negative 25. So back to our function. If we want to find f of pq, we can plug in the numbers we know for each. pq is 2 times 3, which is 6. A is 5, b is negative 25, and c is 47. Simplifying, we get 77, which is one possibility for what f of pq is. On to the second case. Again, same thing. We plug in what p and q is, then use equation manipulation, cancels out the b, and get a is 3, which we can then use to find b, which is negative 21. And for the function, again we plug in the numbers. This time PQ is 2 times 5, which is 10. And simplifying, we get 137. For case 3, same deal. We do the equation manipulation, cancel out the b, get a equals to 2, then use it to find b, which is negative 16. To our given function, and plugging in the known values. For PQ, this time is 3 times 5, which is 15. And again, we plug in for PQ, for A, which is 2, for B, which is negative 16, and C, which is still 47. And simplifying, we get 257. So now we know what f of PQ is for each case. For the first one is 77, for the second is 137, and for the last is 257. And so to find the sum S, we simply add them together, which we get as 471. And since the question asks for the two rightmost digits of S, it would be 71, which is our answer. I hope you enjoyed this one, and I'll see you next time.